Okay, let's imagine that we will have a cannon here that is going to fire at a degree of 65 in relation to the horizontal, and our projectile is going to fly or start the motion at the velocity of 8 meters per second. So this is the data that we have. What they are asking us to find is what is the vertical component of this velocity. So this is basically what we have. We have this vector of 8 meters per second, and what we need to find is related to the horizontal, and here we have the vertical component. What we need to find in this case is the vertical component. So I'm going to call this how we call it. Let's call it the height. No, not the height. Let's call it just V for vertical component. The other piece of information that we have is this angle, which is 65 degrees. Okay, what we need right now is a function that relates the opposing side of this triangle with the hypotenuse. Opposing hypotenuse. The function that is going to give us that relationship is sine. So we know now that sine of, in this case, 65 is going to be equals to our vertical component. Let's call it vert. Our vertical component over our hypotenuse. This is just a simple math that we need to do. We need to use our scientific calculator and find the value of sine of 65. So since we are looking for the vertical component, what we have to do is to multiply these two. If we multiply the sine of 65 times 8, our result is going to be 7.250. That would be our vertical component. Let's twist this problem a little bit. Going back to the previous information, what we have is that the vector for the velocity is equivalent to 8 meters per second. We just found the vertical component on the previous work that we did. This vertical component was found using the function sine. But what if they are asking you for the horizontal component? That will be a different function. So the angle is the same, 65 degrees. In this case, we are looking for a function that relates the adjacent side of this triangle to the hypotenuse. So adjacent hypotenuse. In this case, the function that will help us with that is going to be the function cosine. So cosine of 65 degrees, bless you, is going to be equals to our unknown. I don't have enough room to write down horizontal in here. It's going to be equals to the unknown divided by 8. It's the same mathematical principle. All that you have to do to figure out the horizontal component in this case is going to be just multiplying these two. After you do this, you realize that the value for our horizontal component, this part, is going to be equals to 3.3, in this case, meters per second. Okay, let's review. In this case, our point of reference is this angle. If we are looking for the vertical component, this one, we need to find a function that relates the opposing side to the hypotenuse. This is the hypotenuse of this triangle. because it's right in front of the 90 degrees angle. So this is our hypotenuse right here. So the function that relates our vertical component to the hypotenuse is going to be the function sine. So this will be for sine to relate vertical and hypotenuse. Using the same angle to find the horizontal component will require a different function. In this case, we need something that relates the adjacent side, in this case the horizontal component, and the hypotenuse. For that one, for the horizontal component, the function that will do it is the function sine. So there you go. That's how you use the functions cosine and sine when you are looking for vertical components and horizontal components. The best thing to do is write down your triangle so you can do a good analysis. Another thing that I was forgetting is that make sure that your scientific calculator is set up in degrees. I was doing a previous problem and I forgot that I had my calculator on radians and I was getting a wrong answer constantly. So make sure that your calculator is set up on degrees. I hope you find this helpful.